Hey guys, what's happening? All right, so today we're going to continue our notes for section 13.3, where we are finding the trig functions of any angle. And I know in the first part we talked about using reference angles, and it probably wasn't too clear in the warm-up example that I gave you, but the angle that I gave you was an obtuse angle, but the angle we actually found the trig function for was using a reference angle. Okay, and then we practice finding reference angles, okay? But we really don't need to use reference angles to find the trig functions of angles that I'm going to give you, because we'll be able to use our unit circle, okay? So for instance, let me just kind of show you what I'm talking about, a reference angle. Let's just say we're talking about 120 degrees, right? By the way, what is this in radians? Okay, what is 120 degrees in radians? Okay, well look, you go 60, then 60, right? That's 120. So you go 1 pi over 3, 2 pi over 3. That's one way to do it, okay? So that's 2 pi over 3 radians. But what I wanted to know was, what is the reference angle for this angle right here, this obtuse angle, 120 degrees? Well, remember, it's the distance from this terminal side to the x-axis, right? So how many degrees do we go from here to here? Hopefully you counted 60 degrees, okay? So the reference angle would be 60 degrees. But here's the thing. If you look at, let's just say, what's the sine of 120 degrees, okay? Sine of 120 degrees, well, that's radical 3 over 2. Okay, but if you look at the sine of the reference angle, 60 degrees, look what that would be. That's also radical 3 over 2. Okay, all right. Now, that worked for the sine, okay? Does it work for the cosine? Well, let's see. What's the cosine of 120 degrees? It's negative 1/2. What's the cosine of the reference angle? 60. Well, the reference angle, or 60, is going to be 1/2. The cosine of 60 is 1/2. But look, the cosine of 120 is negative 1/2. Okay, so sometimes it's different. That's why I'm not going to use the reference angle too much, because you have to memorize this one extra thing. Like, you have to memorize which trig functions are positive in which quadrants, okay? So all the trig functions are positive in the first quadrant. Only the sine is positive in the second quadrant. Only the tangent is positive in the third quadrant, and only the cosine is positive in the fourth quadrant. You don't really need to memorize that though, okay? So we're not really going to use our reference angles right now, at least, because we're going to just look at our unit circle, okay? So let me just show you how easy this is. What if I ask you for the tangent of negative 240 degrees? Okay, well, the tangent of negative 240, well, let's find negative 240. Ready? So here's 180, right? Plus I have to go 60 more, right? 60 more to get negative 240. So this is negative 240, right? Unless I did my math wrong. Let's try it again. 180 plus 60, or minus 180 minus 60 more is negative 240. Okay, that's what we're trying to find. So we're looking at this angle right here, which is coterminal with 120 degrees, which the reference angle would be 60 degrees, okay? All right, but look, if all I want is the tangent, remember the tangent is the sine over the cosine, okay? So the tangent of 240 is going to equal the sine over the cosine, so that's radical 3 over 2 over the cosine, which is negative 1/2, negative 1/2. And if you notice, anytime the denominator here matches the denominator there, they cancel, right? Okay. Or if you want, you can change it into this. Watch, this is radical 3 over 2 times, right? Right? And then we're dividing by this. So divided by 1/2 is times by negative 2, right? So negative 2 over 1, same thing. So this divided by that is this times the reciprocal. The 2's cancel, and we're left with negative radical 3. Okay, so there's the tangent of negative 240. Okay, and by the way, just pay attention. Again, this is not necessary for right now, but just again, pay attention. We are in the second quadrant, okay? So just keep that in mind. always try to keep in mind what quadrant we're in, okay? It's going to be helpful for later, okay? So let's try a couple more. Let's try, how about the sine of 210? This shouldn't be too difficult, right? The sine, actually here, let me, I think that's way too easy. Let's do this. How about the cosecant? How about the cosecant of 210, okay? All right, can we do that, the cosecant of 210? All right, well, let's look on our unit circle. Find 210 degrees. Well, here's 180, right? I'm trying to get to 210, so I need to add 30 more. So that's this guy right here. This is 210, okay, or 7 pi over 6. All right, now look what I wanted. I wanted the cosecant, okay? Well, if you arrange your trig functions, remember how I showed you? You put sine, then the cosine, then the tangent. Then what goes next to the cosine is the cosecant, and these guys are reciprocals, okay? These two are reciprocals. What goes with the cosine is the secant. Those two are reciprocals, and what goes with the tangent is the cotangent. Those two are reciprocals. So if I want to find the cosecant of 210, all I have to do is look at the sine, okay, the sine of that angle, and then take the reciprocal, and I've got it, okay? So the cosecant, all right, of 210, so let's go back to 210, that's right here. Okay, so the sine is -1/2, okay? So you can say sine of 210 equals -1/2, so the cosecant of 210 equals, do the reciprocal, that's -2, okay? And then we're done, okay? All right, and keep in mind that was in quadrant 3, okay? All right, let's do one more. See if you can do this one on your own. All right, how about the secant? The secant of, oh, I don't have any more in degrees. Yeah, okay, let's do radians. 3 pi over 9. This might be interesting, okay? The secant of 3 pi over 9. All right, secant of 3 pi over 9. So if you look on your unit circle, I don't see 3 pi over 9, okay? I don't see 3 pi over 9 anywhere. So what that might mean is that we need to reduce this. So can't we reduce this into 1 pi over 3? Okay, so now we're looking for the secant of pi over 3. All right, so here we go, find pi over 3. That's right here, okay? So I need the secant of pi over 3. All right, well, remember, the secant is the reciprocal of the cosine. So what's the cosine of pi over 3? The cosine of pi over 3 is 1/2. So I'll just write this down. The cosine of pi over 3 equals 1/2. Okay, so the secant of pi over 3 is equal to the reciprocal 2. Okay. All right, let's try 2 more. We have time, why not? Okay. Let's try the cotangent of 15 pi over 4. All right, the cotangent of 15 pi over 4. All right, here we go. Again, just pause it if you want to do this without me. All right, so cotangent of 15 pi over 4. So let's find 15 pi over 4, okay? Watch how I do it, because I don't really have it memorized. I just count by pi over 4s, okay? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this guy right here is 15 pi over 4. Okay, and let's see, 15 pi over 4, so I'm looking at this guy right here. All right, and what was it that it asked for? Asked for the cotangent. Okay, so what I want to do is find the tangent of this, okay, and then do the reciprocal. Or you can just do the reciprocal, the cotangent. Instead of doing the sine over the cosine, you can do the cosine over the sine. Wouldn't that be the reciprocal? Right? Isn't the tangent the sine over the cosine? So the cotangent should be the cosine over the sine. Okay, so here we go. That's radical 2 over 2 divided by negative radical 2 over 2. So this equals radical 2 over 2 divided by negative radical 2 over 2. And I don't know if you see that, but it equals negative 1. Okay? It's not really a lot you have to do there. Everything just cancels. Okay? Negative 1. Okie doke. Oh, and let's try something really quick. It tells us not to use our calculator in the book, but I just want to show you in case, you know, you're ever like thinking, oh my God, am I doing this right? Okay, well, watch this. Typically, if you have over 4, that's a 45-degree angle, and anytime you take the tangent or the cotangent, okay, you're going to get a 1 or a negative 1, okay? But let me just show you something, and I'm going to make a mistake on purpose, okay, just to show you guys what not to panic, okay? Watch this. I'm going to push. Well, let's just do tangent, okay? Wouldn't the tangent of this also be negative 1? Okay, so watch. I'll just do the tangent, okay, of radical 2 over 2. So let's see. Tangent of, here, I'm going to put more parentheses here. Square root of 2. Okay. Let's see. Divided by 2. And then close the parentheses there. And then divided by... Okay, more parentheses. Negative radical 2, negative square root of 2. Okay, divided by 2. Okay, and then close the parentheses and watch this. I'm going to hit enter. It'll tell me something completely different. Watch. Look at that. Why on earth did I not get negative 1? Who could answer that question? Why did I not get negative 1? Okay. All right, well, let's check. All right. I'm taking, oh my God, I just took the cotangent of this answer. That's why we didn't get negative 1, okay? But that wasn't the mistake I was trying to make. I'm so sorry. I totally blew my mistake. Cancel that, erase. Let's do this again. I meant to make a different mistake, and I'm sorry. That was pretty funny. So let's do the tangent, rather, of 15 pi over 4. That was so stupid. All right, so 15, where's pi? Okay, divided by 4. Okay, tangent of 15 pi over to 4. It should be negative 1. It's the same as the cotangent. Okay, watch this. And I didn't get negative 1. Okay, that was the real mistake. Why didn't I get negative 1? Oh my God. All right, I'm glad I caught that. So anyway, well, here's why I didn't get negative 1. I'm taking the tangent of an angle that's written in what? In radians. Okay, let's just check my mode. What mode am I in? I'm in degrees. Okay, so if I want to take the tangent or the cotangent of 15 pi over 4, I need to be in radians. Okay, so now I'm in radians, so let me quit that. And now let me do it again. The tangent, okay, of 15 pi over 4. Now I should get negative 1. There you go, negative 1, it works. All right. Okay, guys, so that's it from me. There will be 2 word problems in your book, but there is a very clear example, okay, in the book. So just look at that, and good luck to you. If you need any help, you know where to find me. Bye.